tutorial, we will solve some exercises on relation. Before we start our tutorial, what does it mean, relation? Relation is an association or link between elements. As we said in functions, there is domain and codomain. And here, somehow, it's the same idea. They will mention for you the domain. Sometimes the domain was Z, or sometimes a limited domain, for example, that consists of a specific element. So association is a link between one element to another element. Usually it will be the same set, but sometimes you have made different sets, okay? So there is some properties for that relation. One of these properties, reflexive. What does it mean, reflexive? It means that the element is related to itself. يعني A R A نسميها. أو sometimes we can write it in a pair form. فنقول له A, A belong to R. It is the same when I say A R A. Reflexive معناته every element in your domain is related to itself. The second property, symmetric. Symmetric means I have two elements, A and B. If A related to B, then B related to A. If A not related to B, I don't care about it, B is not related to A. So here you will find that representing symmetric by an implies statement, say A or B implies B or A. So if we want to prove it directly, we assume that A related to B, we have to show that B related to A. You will see later on when we are solving the problem, we should assume the premise, we have to show the conclusion. We are applying a direct proof technique. So you have to remember, whenever we say symmetric, you have to remember this implies a statement. A related to B for the given a given relation, we can conclude that B related to A. Reverse مالها. What does it mean antisymmetric? Antisymmetric mean if A related to B and B related to A, both in my relation, يعني it is asymmetric, we can conclude that in B is equal to A. If we find that A related to B, B related to A, but A and B are not equivalent, that means it is not an antisymmetric. A last property, transitive. Transitive, we have three elements, A, B, and C. If A related to B, B related to C, we can conclude that A related to C directly. So these are the four properties they will ask you to find for a given relation. You should remember the definition for each symmetric. بتلاحظون reflexive A or A, and that's it. We have to substitute. We have just only one simple A. There is no B. A related to itself. That's it. For every element in your domain, your set that you are working on. Symmetric, antisymmetric, transitive, لا. It's an implies statement. An implies statement, to show it, you have to assume the premise, whatever you have in a premise, you have to show the conclusion. If you show it, معناته it is the property, it's true. If you cannot, معناته it is false. For the false cases, you should show a counterexample is enough. There is no need to prove, just give the counterexample if it is false property. If the relation reflexive, symmetric, transitive, we call it equivalence relation. If the relation reflexive, antisymmetric, and transitive, معناته it is a partial order relation. So to decide that a given statement equivalence, you have to check these three properties. The question sometimes said, show that this is an equivalent relationship. You should know directly equivalence, معناته it should be reflexive, symmetric, and transitive. So you have to check only these three properties. In case you find it is not reflexive from the beginning, no need to continue. So it is not equivalent relation because it is not reflexive from the beginning. But we will see later on, sometimes the question is different type. You have to check the properties, even if it is equivalent or not. You have to continue. If the question just show it is equivalent from the beginning, it is not reflexive, so it is not equivalent, and that's it. This is the main properties. Now we will solve different kind of questions. Question number 1, given to us A consists is a set with 1, 6, 3, and 9. So there is 4 elements in our set. R is a relation on A. The question said state its properties. يعني I have to check the 4 properties: reflexive, symmetric, antisymmetric, and transitive. After that, I have to represent each relation by a directed graph. There is many ways to represent a relation. One of them is a directed graph. We will show how to do that. Now, let's see what is in R. R, 3 pairs, 9, 9, 1, 3, and 1, 1. Do you think that this is a reflexive relation? Do you think that this is a reflexive? Why it's not reflexive?
6, 6 not here.
Yes, great. قلنا reflexive mean every element in A should relate it to itself. يعني لازم يكون عندي هني 1 1 included, 6 6 should be included, 3 3 should be included, and 9 9. But actually here we have 9 9 and 1 1. So not everyone. So it is not reflexive. I have to give a counter example. One of the elements are not related to itself. Do you think that this is asymmetric? What does it mean, symmetric?
No, it's not symmetric.
It's not asymmetric. Why?
Because 1 3 is in R, but 3 1 is not. No.
Great. So symmetric mean if A related to B, then must B related to A. And here we find that 1 3 is in our relation, but 3 1 is not there. So it is not asymmetric. Is it antisymmetric?
Yes.
Why?
Because there is 1 3, but there is no 3 1.
Antisymmetric said if A related to B and B related to A, then I can conclude in A will be are the same elements. So here 9 9 and 9 9 is there, so 9 is equal to 9. Yes, it's true for the first pair. The second pair here 1 3, but 3 1 is not there, يعني false premise. No need to check the conclusion because false implies whatever is true. 1 1 and 1 1 is also there, so 1 is equal to 1. So it is antisymmetric. Is it transitive? Transitive mean يكون عندي 3 elements A, B, B, C, then I can conclude AC. صح? So here 9 9, is there any pair related started with 9? No. So there is nothing to be checked with 9 9. 1 3, is there any pair start with a 3? No. So there is nothing to be checked. 1 1, is there any pair started with 1? يعني this is end by 1. I have to start with 1. I have here 1 3. So 1 1 and 1 3. 1 3 should be there. Yes, it is there. So in this case, it is a transitive relationship. Now we have to draw the directed graph. How to draw the directed graph? Usually we have to represent each symbol here with a circle. نسميها state. So there should be 4 states لأن عندي 4 elements in A. 1, 3, 6, and 9. How to represent now a relation itself? 9, 9, it should be represented by each pair should be represented by a line. It is a directed, لازم يكون فيها direction, okay? So it should be draw this small arrow. So it's from 9 to 9. Then from 1 to 3, the direction is very important, the arrows. then 1, 1. Each pair will represent by a arrow in your directed graph. The second relation on the same set consists 9, 9, 3, 3, 1, 1, 6, 6, 3, 1. Now, is it reflexive? Is this relation R reflexive? What do you think?
Yes, it is.
Yes. Why?
Because if we apply the A and A in R, it will be true.
Yes, every element in A related to itself. معناتها 1, 1 belong to R, 6, 6 belong to R, 3, 3 belong to R, and 9, 9 belong to R. We can see them listed here. It is symmetric. Do you think this is a symmetric relation? Yes or no?
Yes.
Yes, why?
No, no.
Yes, it's no. It's not a symmetric relation. Why? Because 3, 1 in my relation, but 1, 3 is not in my relation. So here you can see the last pair, 3, 1, but 1, 3 is not included. So it is not asymmetric. Is it antisymmetric? Yes, it is antisymmetric. Why? بتلاحظون 9 9 and 9 9 there, so they are equal. 3 3 and 3 3 is also included. So for each pair I am checking السيمتريكتي. بشوف انه موجود السيمتريك ماله yes 3 3 الريفيرس ماله بعد 3 3 3 is equal to 3. 1 1 and 1 1, 1 is equal to 1. 6 6 and 6 6, also 6 are equal. 3 1, but 1 3 is not there, so I will not check if they are equal or not. Okay, so in this case it is anti-symmetric. It is a transitive. What do you think? Is it a transitive? How to check the transitivity?
I didn't understand the transitive.
The transitive يعني A related to B, B related to C, directly the pair AC will be included. How to check that? أروح pair by pair. 9 9. في عندي شيء هني start with 9? No. So خلاص
No.
الcondition الpremise مالتي false. احنا قلنا false implies anything, I don't care, it will be true, صح? So the condition that I have two pair, one end by B and the other one start with B is not there. So there is nothing to be checked, okay? فأروح أشيك 9 9 في عندي pair يبدي ب 9? No. So skip it. 3 3, is there any pair start with 3? لأن this is end by 3. عندي 3 1. So 3 3 3 1 الAC بيكون 3 and 1. 3 1 is there. Yes, it is there. It is already here. The same pair. في عندي another pair start with 3? No. So I will skip down this. Now here 1 1. Is there any pair start with 1? No. So there is nothing will be checked. بروح 1 6. Is there any pair start with 6? No, so there is nothing will be checked. بروح عند هني 3 1. Is there any pair start with 1? Yes, which is 1 1. So 3 1 and 1 1, I will get a 3 1 as a result. 3 1 is in my relation? Yes, it is in my relation. So in this case, it will be transitive. I have to check all possible the transitive cases. Okay, is that clear, dear?
Yes,
it
is clear.
We will see later some problems such that it is not a transitive. We will see the counterexamples, okay? Now here in our cases, both of them are transitive. So we will check later for non-transitive cases. Now to draw the directed graph again, we have to represent each one by a circle. الستيت each element يكون عنده state. بعدين عقبها I have to represent each pair here with an arrow. ف 9 9 3 3 1 1 6 6 and 3 2 1. This is the directed graph. The last problem in this exercise we have the relation in a form of a general form, not a listed pairs. Okay, so we have to understand what does it mean, the definition for that relation. It said that it will contain the pairs A and B belong to A square, يعني A cross A. يعني الدومين and the codomain, both of them are the same set A. Such that A plus B, the summation of both elements, are less than or equal to 10. Now, our domain here is limited, so I can list the pairs. It's not Z, for example. In case it is Z, I cannot list the pairs. Here we have only 4 elements. So can I represent what is in R? I have to check. راح أسوي A cross A، يعني أبتشيك 1R1 1R6 1R3 1R9. Then I will check 6R1 6R6 يعني related to 6 6R3 and 6R. I will check all them يعني 16 pairs. I will check them. If they make the condition true, I will add them to my R. Now let's see here. 1R1. 1 plus 1 is 2, less than 10. Yes, so I will include 1, 1 in my relation. Then I will check 1, 6. 1, 6. 1 plus 6 is 7, less than 10, so it will be included in my. 1 plus 3 is 4, 4 less than 10. Yes, so I will include it in my R. 1 plus 9 is 10, 10 less than or equal to 10, so it will be included. Then I finish from 1. I will start now with the second element 6. 6, 1 is included. يعني 6 plus 1 is 7, less than 10, so 6th one will be included in my R. بعدين أشيك 6 6 6 plus 6 less than or equal to 10? No, it's a 12. 12 is greater than 10. So I will not include 6 6 in my R. Then I will check 6 3. 6 plus 3 is 9. 9 less than 10? Yes, I will add it. 6 9. 6 plus 9 is 15. 15 is greater than 12, so it will not be included in my R. I finish from 6. Now I will go to element 3. A 3 1, yes, the total is 4, less than, so I will add it. A 3 6, yes, 9, I will add it. A 3 3, less than 10, so I will add it. A 3 9, total is 12, greater than 10, so I will not add it. Now I will go with the element 9. 9 1 is 10. It will be added. 9 6, 15, no. 9 3, 12, no, greater than 10. 9 9 is greater than 10. So again, these pairs will not be added in my relation. Now here I end by the relation كانت general form definition. I put the listed pairs inside. Now here easily I can decide if it is reflexive or not. What do you think? Is it reflexive?
No.
No, why?
9 9 not included.
9 9 is not included. 6 6 is not included. So I have two possible counterexample to say it is not reflexive. Is it symmetric? What does it mean symmetric? It means if A related to B, then B related to A. يعني if A plus B less than or equal to 10, then we can conclude in P plus A less than or equal to 10. And we know that addition commutative relationship تبادلية عادي A plus B is equal to P plus A. Okay, so in this case, this is a symmetric relationship. And how to do that? You can prove it as a general case. Yes, you can instead of proving it, you can check all possible cases. يعني 1 6 and 6 1 is there, 1 3 3 1 is there, 1 9 9 1 is there, 6 3 3 6 is there. So in this case it is symmetric. Or you can just write since A plus B is equal to B plus A, so it will be asymmetric. Is it antisymmetric? It is not antisymmetric. Why? Because 1 3 here and 3 1 is here, but 1 and 3 are not equal. You have to give a counterexample. Show me that A are B and P are A included in my relation. It is a symmetric case, but A will P are not equal. Is it a transitive? What do you think? Is this a transitive relationship?
I think yes, because of the commutative law of addition.
Not a must, not a must. To say yes, you have to check all possible transitive cases, okay? But here I can see that 6 3 related to R, 3 6 is related to R, but 6 6 related to R. يعني إذا عندي رقمين مجموعهم أصغر من 10، هل المجموع الأول مع الثالث بعد راح يكون أصغر من 10؟ This is not. So this is not a transitive. Maybe for example here 1 6 6 3 1 3 is related to my relation. But I can see some cases that the total of A plus C is greater than 10. So this case is not a transitive. For not cases not properties لازم نعطي counter example. For the true يا أن احنا we have to explain it as a general case, or we have to check every possible cases that make my statement true. So now to draw directed graph again, we have to draw circles, then we have to represent each pair by arrow. يعني 1 1 1 6 1 3 1 9 6 1 6 3 3 1 3 6 3 3 and 9 1. Each pair should be represented by an arrow in your directed graph. This is one type of questions. Is that clear? So we can shift for the second question.
Yes, clear.
Good. Now we have a set A with 0, 1, 2, and 4. We have again 4 elements. The question is up to you. Give a relation S, they name it S, such that it satisfies the condition. They write here for you, for example, S is a relation that is reflexive, symmetric, antisymmetric, and transitive. من يقول لي كلهم should be positive معناته just put the pairs where they make it reflexive. Do not add any extra pairs, okay? فبس مجرد أحط each element related to itself and that's it. لأن they want it to be symmetric and antisymmetric at the same time. I will never make it symmetric and anti-symmetric at the same time if I add extra pairs. يعني مجرد أحط له 2 1 1 2 it will not be an anti-symmetric. To avoid one symmetric one anti-symmetric أخليهم both of them true properties. I will not add any extra pairs. For example, here S, they wanted to be reflexive, symmetric, and not transitive. So here, to make it reflexive, I have to add 0, 0, 1, 1, 2, 2, 4, 4. This should be added to make it reflexive. I have to make it symmetric, so I can keep it as it is, and I can add extra pairs, okay? So in this case, for example, if I add 1, 2, I have to add 2, 1 to make it symmetric. Okay, but in case I add 1, 2 and 2, 1 and I stop here, it will be transitive. To make it not transitive, I have to add extra pairs. But in this case, I have to remember whenever I add a pair, I should add its reverse. So to make it symmetric always. So in this case, the trick here, I will add 4 pairs. These two symmetric, these two symmetric, but 1, 2, 2, 4, the result should be 1, 4, and 1, 4 is not added here to make it not transitive. لأنه هو يبيها not transitive. Okay, so you have to add extra pairs to make it not transitive. Is that clear about this trick? Now, they want from us a relation S that is symmetric and transitive only. معناتها they don't want it to be reflexive. They don't want it to make it anti-symmetric. So in this case, you have to put pairs inside S, just a suggested one, that to make it symmetric, I will add 1, 3 and 3, 1. So this is a symmetric case. The result to make it transitive is 1, 1. So I include 1, 1. You can write any relation. Maybe some student, they will add, for example, 0, 0, 4, 4. They will not add 2, 2. It's also not reflexive. So it's okay. It is not anti-symmetric لأن 1, 3, 3, 1 and 1, 3 are not equal. So here we make it symmetric and transitive only. The last one, طبعا هني this is just only a suggested solution. You may get different relationship and it's correct. Okay, so such kind of a question, they are a little bit open. So whenever you put the relation, you should make it correct according to the property listed in the question. Now the last one, they want S such that it is not reflexive, not symmetric, and not transitive. So to make it not reflexive, you have to miss one of the pairs that are related to itself. In addition, it is not symmetric. So when you add a pair, never add its reverse. So it will be not a symmetric. Not a transitive. For example, I add 2 pairs. The result of the transitive case will not be included. So it will be not a transitive. Is that clear? So هاي الأسئلة generally they are open. I found that mostly in exam, they give you a relation and they ask you to select from checkboxes the properties. Okay, so you have to be very clear when you are selecting. It is not not reflexive, for example, because you know what does it mean reflexive. So you should understand the meaning of these properties. Any more questions regarding this problem?
No, thank you.
This question number 3, they are a relation for unlimited domain. Okay, so we cannot list them because they are unlimited pairs. Here, for example, the question said, show the properties, يعني must you show the properties. لازم ال 4 properties you have to check them. Then state if it is equivalent or partial order. So in this case, must you list the properties, the 4 properties? And you should decide for each property if it's a true or false. And then later on, you should decide if this is an equivalence or not. This is a partial order relationship or not. You should understand the meaning. Here, for example, for all A and B belong to Z. So our domain is Z, such that A related to B if and only if. يعني the meaning of A related to B mean in A times B is equal to 0. Now to check a reflexive, we mean is A or A belong to every element related to itself. يعني A or A. Is this belong to my relationship or not? What do you think? This is reflexive or not reflexive?
I think
يعني
not
zero.
reflexive.
Yes, it is not reflexive. And can you give me a counter example?
1, 1.
Yes, 1, 1. So this is not reflexive. 1, 1 is a good counter example. 2, 2 لأن related إن تكون equal to 0 بس في case واحدة 0, 0. So this is not a reflexive. You can give any counter example. A R, A does not belong to R. يعني البير A does not belong to R, you can give anyone. Now, symmetric or not? What do you think? Is it symmetric? يعني
I think yes.
A related to B, I can conclude that B related to A. يعني A ضرب B يساوي صفر. Can I conclude in B times A equal to 0 also?
Yes,
Yes.
if B is equal to 0.
Yes. So here I am assuming in A related to B. قلنا we have to show it as a general case لأن our domain is unlimited, so we will prove it directly. I will assume in A are B. I have to show that B are A. And since A are B معناتها A times B is equal to 0, I know that B times A is equal to A times B. So B times A is also equal to 0. So B are A, so it is symmetric. It is anti-symmetric. What do you think?
No.
No. Why?
Because it's symmetric and can't be
Yes.
anti-symmetric.
Usually it will be not. Okay. So it is anti-symmetric. No. You have to give a counter example. One of counter examples, possible ones. لو حطينا 5 0, the result of multiplying them is 0. 0 5, the result is 0. But 0 and 5 are not the same element. So it is not anti-symmetric. Is it transitive? يعني لو اخترت 3 أرقام A times B equal to 0, B times C is equal to 0. هل هذا معناته إن A times C is equal to 0?
No.
I think yes. In most cases, A and C will be 0
I
and
don't
0.
want most cases. I should say true if it is for all possible cases. لأن this is a universal statement. If one case make it false, it will be not a transitive. Okay? We are proving general statements.
Okay, it will be true for all the cases. Because
Now,
0 and 0 exist.
No.
No, not always. 5 times
5.
0 is equal to 0.
5,
0 times 6 is equal to 0. But 5 times 6 is not equal to 0.
Okay.
Correct or not?
Yeah.
The order and the pairs are very important. If you say 5 times 0 is belong to R, 0. 6 times 0 belong to R. 5 times 0 is belong to R. Yes, it is a possible case. But here, no. لازم يكون عندي I end by 0, I start by 0. But here we have different elements, right? The multiplication of them is not equal to 0. So this is not a transitive case.
أقدر أستخدم اللي في الأنتي سيمتريك المثال؟
تقدر تستخدم أي مثال. But you should be very يعني selective in your counter example. You should give me, there are many counter example for each case. Many out there. This is just a suggested counter example. بس لازم يكون ال counter example a good counter example. يعني احنا في البداية slide number 1 we show what does it mean transitive. قلنا A are B and B are C, we can conclude A are C, صح? This is what does it mean transitive. You should give me a counter example that make your premise true. يعني A are C and sorry A are B and B are C is true, but A are C is false. لازم يكون good counter example. واضح؟
يعني
مثل ما قلت الانتي سيمتريك counter example can make the transitive also not a transitive. So it will be a good counter example. Is that clear?
Clear.
Now, is it equivalence relationship? Is it partial order? What do you think? قلنا عشان تكون equivalence لازم تكون reflexive, symmetric, transitive. So it is equivalence or not?
No and no. Both of them
Not
no.
equal.
في البداية
Yeah.
not reflexive, not transitive معناتها it will be not for equivalence will partial order. What about this definition? It said, I can say that A related to B if and only if 7 divide A square minus B square. احنا قلنا divide mean إن A square minus B square is divisible by 7 or multiple by 7. Okay? So now, what do you think? Is this is a reflexive relationship on Z? يعني A are A in another way. What does it mean ARA? ARA معناته إن A square يعني I have to substitute here A square minus A square divisible by 7. What do you think? A square
Yes.
minus A square is 0. 0 divisible by 7? Yes. I
Yes.
can divide it over 7 without any remainder. So this is a reflexive relationship. I'm just substituting instead of two simples A and B, I am substituting with A and A. Okay, and I will see is that true or false for every element in Z. Because here the relation for unlimited set. Is it symmetric? What does it mean symmetric? If A related to B, then can I conclude that B related to A? So I am assuming in A related to B. I have to show in P related to A. This is how to prove it directly. I am assuming, I'm saying let A related to B. What does it mean A related to B? It's mean, according to the definition, in A square minus B square is 7K. Can I conclude from that in a P square minus A square equals 7W, for example?
Yes.
Yes. Why?
We can manipulate the equation. So it will be
Take
B squared
minus
minus
as a common. يعني just take minus 1 as a common factor. You will get A square minus B square. This is can be substituted with your assumption here, 7K. So minus 7K divisible by 7 or not? For sure divisible by 7. Negative or positive values. Okay, so here in this case we can say that this relation is a symmetric relation. Is it antisymmetric? To say false, give me counterexample. To say true, you have to prove it that A will be R equal in case it is symmetric. If I put two values such that these values make it divisible. For example, I put 7, 0. 7, 0 belong to R لأن 7 square minus 0 square is 49. 49 is divisible by 7. 0, 7 also belong to R لأن minus 49 also belong to divisible by 7. So this is belong to R. But 0 and 7 are not equal values. So it is not antisymmetric. As your friend said, usually if it is symmetric, it will be not antisymmetric. But this is not always, because there is some cases it is symmetric, but it is also antisymmetric. Is it transitive? للترانزيفيتي قلنا لازم يكون A related to B and P related to C. We have to show in A related to C. So we are assuming these two true. We have to show A related to C or AC belong to R. I am assuming ARB. What does it mean ARB? It means A square minus B square is something multiple by 7. What does it mean BRC? BRC mean in the P square minus C square is something multiple by 7. Now, can I conclude from these two equations in the A square minus C square is something multiple by 7? احنا عندنا we can add two equation لأن عندي هني minus B وهني B square. So I can add them. So it will be A square These will cancel each other. Minus C square will be equal to 7K plus 7W. Then you take 7 as a common factor. It will be K plus W, so it's 7H. So if I represent A square minus C square in a form of something multiple by 7, معناته A is related to C. So in this case, it is a transitive. Now, what do you think? This is equivalence relationship or not?
No,
Why it is not equivalence relation?
not antisymmetric.
No.
No, it's equivalent.
عشان أشيك الإكويفالنس اللي يهموني reflexive symmetric transitive، هذه ما تهمني. عشان أشيك الإكويفالنس لازم يكون reflexive symmetric transitive, and this is actually what we have. It's a reflexive symmetric and a transitive, so it is an equivalence. Is it partial order relation?
No.
حق البارشال اوردر لازم تكون reflexive anti-symmetric وtransitive. But it is not anti-symmetric, so in this case it is not a partial order. Okay, لازم أعرف equivalence أشيك بس هالثلاثة properties, these three properties. I will not check anti-symmetric for equivalence, but I have to check it for partial order. What about this problem? X related to R if and only if X times Y is greater than 0 on Z. Again, this is unlimited. Do you think that this relation is reflexive or not?
I think no. Because
Why?
0 and 0, they are not.
Yes. So here the relation said X time Y is greater than 0. If I am checking a reflexive, I have to check X time X or A times A. يعني it's related to itself. In case it will be A square is greater than 0. Is A square greater than 0 is correct for all X belong to Z? It will be correct for the positive values. It will be correct for the negative values. But with the 0, it will not be correct. So there is only one element make it false. So it is not reflexive because of the 0. 0 belong to Z, but 0, 0 does not belong to R لأن there is no equal. مجرد يحط لي equal, it will be reflexive relationship. Is it symmetric? يعني if A related to B, can I conclude إن B related to A? يعني AB greater than 0, can I conclude in a BA greater than 0 also?
Yes, because it's a multiplication.
Yes.
Same as the summing.
So this is true لأن if I want to check B times A is greater than 0 from A times B, I can conclude in a B times A is greater than 0 لأن the product is commutative relationship. So it is a symmetric. Is it anti-symmetric?
Yes, it is antisymmetric.
No.
If yes, why? If no, why?
No, because
if no, I need a counterexample.
We have 1, 3, and we have 3, 1.
Yes, 1, 3. It's belong to R لأن 1 times 3 is 3 greater than 0. 3, 1 belong to R because 3 times 1 is greater than 0. But 1 and 3 are not the same elements. They are not equal. So you have to give a counterexample to show a not antisymmetric. A transitive. What do you think? Is it a transitive? The transitive mean I have to assume in A related to B and B related to C. This is my assumption. It's true. I have to show in A related to C.
Yes, it is transitive.
Yes, it is a transitive. I have to assume this. So what does it mean A related to B? It's mean in A times B is greater than 0. What does it mean P related to C? It means P times C is greater than 0. So we know that A times B is greater than 0 معناته either A and B are positive or A and B are negative عشان يكون greater than 0. So if I am assuming that A and B are positive, B already positive from my assumption. So again, to make the product of P and C greater than 0 معناته C must be positive. In case I assuming that B and A are negative, to make this is also true, is C must be negative. So these two inequality equation, it will be true in case all A, B and C are positive or A, B and C are negative. So I have only two cases. لازم كلهم يكونون positive أو كلهم يكونون negative. So in case all of them are positive أو all of them are negative فأكيد A times C will be always greater than 0 لأن A و C بيكونون both of them positive أو both of them is negative. So I can conclude in A or C. طبعا احنا we are not discussing proof mainly فما حطيت الcases والله she just an explanation to show that. Okay? But actually as we said we are proving it directly. So we can conclude in ARC in case ARB and BRC. So it is a transitive. Now it is equivalence relation. What do you think?
No, it is not.
No, because it is not reflexive. And because it is not reflexive, it is not equivalence and it is not partial order. لأن reflexive is a common property for two type of relations. And I think this is the last question for this part. Now, what do you think? Now you are you have enough experience to give a judgment from the general view. If I say that x related to R mean x plus y equal to 0, do you think that this is a reflexive relation? هل لو خديت الرقم مع نفسه جماعته I will get 0 for every element in Z?
No.
No. So it is not reflexive. You have to give any counter example. 5, 5, 6, 6, minus 1, minus 1. أصلا الرقم الوحيد اللي أجمعه مع نفسه 0, it will be only 0. So here you have يعني infinity number of counter examples. Is it symmetric? A relation is x plus y equal to 0. So I am assuming in A plus B equal to 0, I have to show that P plus A is equal to 0. Is that true or false? Yes.
Because 0, 0.
No. If A plus B, this is from my assumption, it's true. مجرد لأن summation is commutative relationship تبادلية فأقدر أقول إن A plus B is equal to B plus A. فبس مجرد أبدل هني it's equal to 0. So in this case B R A. لأن عملية الجمع عملية يسمونها إبدالية. Okay, so in this case, I can conclude in B plus A equal to 0 if A plus B is equal to 0. So this is a symmetric relation. Is it antisymmetric? What do you think? Is it antisymmetric? Mostly it will not be antisymmetric.
No.
But you have to give a counterexample.
Minus 5, 0. And 5, 0.
Minus 5, 0 does not belong to R. Minus 5 plus 0 is equal to 0. هاي الريليشن راح يكون فيها يعني if you try to guess what is the pairs inside the relation, it will be minus 1, 1, 1 minus 1, 5 minus 5, minus 5 5. The total of the elements in the pair should be equal to 0. يعني you have to give a good counter example. Some pairs that belong to R. لما أقول 5 0 5 0 does not belong to R لأن what is the pairs inside the R? Integer and its negation اللي هو negative value of it. يعني 5 وماينس 5. 5 and minus 5. Minus 5 and 5. These two are belong to R. But 5, 0 does not belong to R. Okay? So you have to give values that already belong to R. Minus 5 and 5 belong to R. 6 and minus 6 belong to R. Okay? The total, whatever the order is, will be both of them 0. So minus 5 and 5 belong to R. 5 and minus 5 belong to R, but 5 does not belong to 5. Minus 5. تحطوا لي counter example غلط. Some pairs does not belong to R. This is not a good counter example. لازم تفهمون what is the kind of pairs inside the relation من خلال the definition of the relation. Now, is it a transitive?
No.
No, why?
And the counterexample is if we assume that -1 and 1 belongs to R, and also 1 and -1.
Example here, similar to this anti-symmetric case. Yeah. Let's say that minus 5 and 5 belong to R. 5 must belong to minus 5. So here the A and the C are the same elements. So the total of them is not equal to 0. It will be minus, 2A. So in this case, this is also not a transitive. You have to give a counter example. For example, 1 and minus 1, minus 1 and 1, but 1, 1 does not belong to R لأن التوتال مالهم is 2, not 0. ممكن تحطون any counter example here such that the result will not belong to R. Now, is this equivalence relation? Is it partial
Not
order? Not.
No.
So it is not partial, not equivalence, because it is not reflexive. The last questions in today's tutorial, the question is different. Do not check the properties. The question said, prove that R is equivalent. So R is equivalent. You have to show that it is equivalent. To show it is equivalence relation معناته 3 properties should be true for it. Reflexive, symmetric, and transitive. You have to list the properties. That means you know what does it mean equivalent relation. These 3 properties should be true. So how to check reflexive? What does the relation mean? Relation A related to B if A plus 3B is divisible by 4. Is it reflexive? Reflexive معناته is A R A؟ يعني هل كل element related to A? What does it mean ARA? أروح أعوض في هني. ARA معناته A plus 3A is divisible by 4. What is A plus 3A? It's equal to 4A, which means it is divisible by 4. Okay, so it is reflexive. Is it symmetric? Is it symmetric? What does it mean symmetric? It means if A are B, can I show that B are A? This is what does it mean symmetric. Now I am assuming in A related to B. I am assuming the premise. I have to show the conclusion B are A. So my work is to show this. This is my assumption. Now I know that A are B mean, according to the definition, A plus 3B, something divisible by 4. What is B plus 3A? So I will try to find out what is B plus 3A. What I have to do, I will take A from my assumption and I substitute here. So it will be B plus 3. Then I will take A from my assumption since it's true. It's equal to 4K minus 3B. So I will substitute the value of A from my assumption. Then I will distribute the 3. It will be equal to B plus 12K minus 9B. B minus 9B بتكون minus 8B. So it will be 12 minus 8B. I will take 4 as a common factor between 12 and minus 8. So it will be 4 times 3k minus 2b. 3k minus 2b, this will be something integer since the p and the k are integer. So it will be 4w. So I prove that p plus 3a is something multiple by 4. So it is symmetric. Is it a transitive? يعني إذا A related to B دائما حطوها قدامكم. Just write it in front of you. What does it mean a transitive? It means if A are B and B are C, I can conclude in A are C. So I am saying let A are B and B are C. This is true. I have to show that A are C. What does it mean ARC? I have to show that A plus 3C something divisible by 4. This is my goal. I have to show it. This is my assumption. It is already true. So in this case, I will say, what is ARP? It is mean A plus 3B something multiple by 4. What is PRC? It mean in a B plus 3C is something multiple by 4. Now my goal is to show that ARC. What is ARC? It is A plus 3C. Can I prove that this is multiple by 4? This is my goal now. What is A? A from the first assumption equal 4k minus 3b. Add to it 3c. What is 3c? 3c from the second assumption, it's equal to 4w minus b. I'm just substituting, okay, from my assumption. Something given, it's true. So let now simplify it. It will be 4k plus 4w minus 4b. I will take 4 as a common factor. So it will be 4 times k minus b plus w. This will be an integer value, so it is 4h. So it is a transitive. Now it is reflexive, symmetric, and transitive. Then it is equivalence relation. It's very important to read the question carefully. If say to prove it is equivalent, so it is equivalent. You should work on showing a reflexive is true, symmetric is true, and a transitive is true. Do you have any questions? So this is the tutorial for today. You have to focus on what does it mean each property. This is slide. You have to focus on it. Later on, if you have infinity domains, you will do a direct proof for these implies statement to represent the property itself. يعني symmetric يقول لي ARB implies BRA. So I am assuming ARB, I have to show BRA. Direct proof. And similar to the others. إذا كان عندي relation on a limited domain, you can list the pairs and you can check manually. Is that clear? Do you have any more questions? So this is our tutorial for today. Wish you all the best in your test, inshallah.